So let's look at this question here, which is on binomial distribution, I believe. So let's say I can do this proficiently. So data is taken from the year 2015 Diamond High Paper 2 question 7. So data is transmitted in bytes where each byte contains 8 bits. Okay, great. So probably of a bit being corrupted is its transmission is 3%. A byte is considered corrupted if it contains at least 2 corrupted bits. So yep. Let's see how we can do this. So assume all the bits are not corrupted prior to their transmission. Find the probability that a randomly chosen byte is corrupted during the transmission. So first of all, we need to just define the distribution matrix. So let X be the number of corrupted bits out of 8. Because every 1 byte you have got 8 bits, right? So for a randomly chosen byte has got 8 bits, so this has got 8 bits. 8 bits. 8 bits here. So every 1 byte has got 8 bits. So this case here, the first part should be quite okay. The first one will be required probability. This will just be P X also. I'm just gonna name this as binomial. Every 1 which is corrupted is 3%. Okay. So there you go. So I just put this here. Then after which required probability is corrupted. So contains at least 2. So at least 2 is here. So we can just take 1 minus px at most 1. Okay. So key in calculator. This case here 1 at most 1. So this case here 1 CDF, right? So this case clear it 1 minus CDF. Binomial CDF at least 1, so 8. Every 1 is 3%, and we need like at most 1. 0.02234. So this is 0.02234. This will be 0.0223 SF. That's pretty okay. Let's look at the second part there. Second part, we have got, given that a randomly chosen byte is not corrupted during its transmission, so means this 8 bits here is not corrupted. Find probably that that it contains no corrupted bits. Okay, great. So no corrupted bits will mean that px equals to 0, no corruption at all. So part 2, required probability. This will just be p. What we need is actually not corrupted, meaning 1 not corrupted. Okay, and x equals to 0. So no corrupted, we know that is px. No corrupted is intersect with not corrupted, which is x at most 1, right? What we did just now. So this is px at most 1. So not corrupted will just mean that x less equals to 1 at most 1. Okay, so let's look how we can do that. So x0 intersect with x1 will just be px0. So that is pretty okay, I think. Then this is px at most 1. So just key in calculator 0 PDF binomial PDF here. We need bit 0. So we have 8 and this is 0.03. And we just put this as 0. Divided by this CDF here. Hopefully it's 8, 0.03. Put this as 1. Okay. This is 0.80165. So this case here will be 0.80165, which is 0.802 3SF. Okay, great. Let's look at part 3. So for part 3, find the probability that between 5 and 10 bytes are corrupted during transmission of 100 bytes. Okay, great. Find a probability. So do you have 100 bytes, right? 100 bytes. So now whether you're corrupted or not. So it's another binomial distribution. So every one, I'm going to write this down again. So for part 3, I'm going to let y let y be the number of corrupted bytes. Now every bytes have got 8 bits, right? Out of 100 bytes. That is the important part. So you must be able to understand that. Okay, so now is every 1 byte has got a chance to get corrupted or not. So this y here, what you do is you just put a binomial and 100 bytes. Every 1 byte would have got this chance of failure is what? Given that a random byte is not corrupted, probably that corrupted, okay? Number of corrupted bytes. So this part 1, the answer from 1, which is 0.02234. Every 1 byte is corrupted is this, right? So now we want the required probability. Probability will just be P. Between 5 and 10 bytes are corrupted. So between 5 and 10. Okay, so this case here will just be P y at most 10 minus of P y at most 4. Don't include 4, discrete, okay? So this case here, we're just going to put in distribution, binomial CDF. So you have 100 bytes here, and every 1 byte have got, what's the chance here? 22340, 0.0223410. 0.22340. You can just put a 0 because I truncated it. Then I'll put this as 10 and minus of 2, 4. Okay, so that's it. Paste it. 0.073. 0.073. Sorry, I misinterpreted the question. So between, not inclusive, I never see that is. So between meaning not inclusive. So I'm just going to put this as not inclusive and not inclusive here. So this case here will just be, you do not want the class of 10. So this would be minus of 5 here. Okay, that's about it. So I'm just going to key in my calculator. I'm going to change it. This would be 5, is it? Okay, this is would be 9. I'll put this as 5. Okay, in calculator, 0.24938. So this is 0.24938. 3SF. Okay, that's how I do this question here. Let's look at the last one. So for the last part, in another transmission system, the probability of having at least 3 corrupted bytes during the transmission of 20 bytes is 0.85, and probably that a bit is corrupted during this transmission. Okay, so I'm going to use the same binomial distribution. So but now is let k be the number of corrupted bytes out of 10 bits. Sorry, bits. Out of 8 bits. Okay, so that's the thing there. So finally, what we need to do now is essentially just write down k, and in this another transmission system, same thing. You put this as 8, and this would just be what do you call it? This would be p. Okay. So I'm gonna let the probability of a corrupted bit p. That is the first thing that I wanted to do. Okay. So in this another transmission system, so once we're done, I get this as my just 1 byte. Okay. Now you're saying that if you transfer 20 bytes of the and you have got there you go, you transfer 20 bytes. Okay, you having at least 3 bytes corrupted during the, there's so many confusing, but because of bits and bytes, right? So this is just a bits first. So you need to do the same thing as the previous one, meaning to calculate what are the chances where 1 byte is corrupted. So it's corrupted at least 2. So this case here, so chances, probability of, so this case here, I'm gonna write it down. Probability of a corrupted bit using the new system would be same thing, pk, pk, maybe I'll just write it down. So this one here is very important. Corrupted bit would be pk, at least 2, right? So this is 2 here. So same thing, which is 1 minus pk at most 1. Okay. Now the thing now is we are told that 20 bytes 0.85, right? Find probably that the bit, so we need to find the b, find b. So we're told that having at least 3 corrupted bytes during a 20 bytes transmission would be 0.85. So there's another probability. So now let L be the number of corrupted bytes out of 20 bytes. Okay, this is the annoying part, because this is like inception, like you just keep convoluting, like just keep having more binomial within a binomial. So this will be 1 minus p k less than equals to 1. Okay, so there you go. So once this is done, find probably that the bit is corrupted during transmission. So we need to find p now. So probability of at least 3 corrupted bytes during transmission of 20 is 0. So this we could run a p l having at least 3 corrupted. So this is number 3 is given by 0.85. Okay, great job. So now we can write this down. Okay, so I need more space here, so I'm gonna just move it to the other side. Let me just put this the other side here. This is like, okay, so maybe I just craft it out. So in this case, you're gonna have 1 minus p l at most 2 equals to 0.85. Of course, I would like to bring the 0.85 to the other side. That's what I usually like to do. 1 minus 0.85, which is 0.15. So 0.15 minus pl at most 2 equals to 0. So I'm going to solve this by using the calculator here. So how do we solve it? First part is just need to put down this. So this is the probability here. Annoying, I know, very, very annoying. It's so many things going on, right? So let me just key in calculator and show you how this is being done here. Okay. So this part here. First of all, we have got this one. So L, I need to key this in. So let's go to L. Then I'm going to put this as 0.15, and I'm going to put this as minus CDF. So this is normal binomial CDF. I put this as 20, and the P here, oh my goodness, is 1 minus. So you just put in this at most 1. So meaning to say distribution binomial CDF, and I'm going to put this as goodness 8 comma, I don't even know what's the syntax for this. Okay, I think we just do this first. Okay, so let me just quit to the main menu. So this is NP CDF. So NP and the number here. So the number here, this will be my X then. Then the number will be 8, and then this will be 1. Right? So because I need this to be 1, this system here. Okay, so it's a lot of things to bring in. I know, a lot of moving parts. Just bear with me. This, I need to key this in. So I repeat, go to here, then I'll just put in this second distribution, normal CDF, because I'm keying this in. Normal CDF, then this will just be sorry, not normal CDF, binomial CDF. Then I'll just put this trials as 20, and this I'm going to put this as 1 minus second distribution CDF again, but this time CDF will be 8, comma x, comma, and putting this as 1. The x value here will be 2. Okay, so there you go. Paste it. Right now you are solving for x, which is actually this what do you call it, the probability. So it's rightful to just put this as 1 and 1. So they zoom that the area there and find the answer. Okay, so this will be our answer here. It's quite tough. I think the problem with this question here is you have too many moving parts, which is like, oh, which part is which, and you really need to orientate in terms of like which binomial is which type binomial. I hope you understand what am I doing here, but if you don't understand, please let me know. So from GC, what we could calculate is 0.11. Okay, so using GC, P is given by 0.111. Okay, so there you go. Let me just write this down. Yeah. So this is how you do this question here proficiently. If you have any question or comments at all, please let us know. Keep practicing, and I'll see you in the next question.